This is a production of Cornell University.
Well, I had a good week this week, Doug. I took the kids to Yankee Stadium.
Oh, that's fun.
We took our turf class to Yankee Stadium with some additional people interested. We had about 25 people we took down to visit my old college pal, Dan Cunningham. And of course, you've been down there with me as well. And you know, it reminded me of when I taught at Madison. I used to take them up to Lambeau.
Yeah.
Yeah, we had pictures of the class at the center of Lambeau, and then we went. We took the train. We took a bus down to Yankee Stadium, and then got on the subway and went down to Central Park and visited Zach Holm, who's the director of turf care at Central Park. Did some grass ID of the ryegrass and poa in the field there, and then hung out a little bit at Sheep's Meadow.
Super cool.
Yeah. Tuesday, that was Monday. Tuesday, we got up and went out to Delhi, SUNY Delhi, where we had a walk and talk promoting the apprenticeship program that the New York State Turfgrass Association is working on with a bunch of the superintendent organizations, Tyler Bloom's outfit. And there are about 1,000 students pursuing apprenticeships in Greek keeping, grounds management in New York State. So this is a very exciting time, and we got to meet and see some of the students at Delhi doing projects on the golf course. Got to interact with Tom Kaufman, who's been the superintendent there for many, many years now. And so it was a great visit, and actually we got to see some robotic mowers. MTE was there. That's Matt Simon, former superintendent, now selling robots for MTE. And it was very interesting because, you know, from a workforce perspective, you know, automation and apprenticeships, those apprenticeships better be teaching technological skills, because a lot of what these folks are going to be doing is going to be involving technology. Now, assumedly so, this generation, younger generation, will be more comfortable integrating technology into their work life. Okay. You know, Carl, thanks for joining us. Glad to have you. I'm on time for a change. It's so great.
I owe you.
I was literally sitting there like, okay, what do I do? Carl's not here. Okay.
I owe you now.
Yeah, for all those years, I've been late, right? But, you know, we got dog pictures. How about a shout out for the cats? Now, I'm not a big cat guy, but I got 3 barn cats, and cats have their usefulness. They're not very interested in you per se, but they are interested in some of the things that bother you around your facility. And then my man, Will Benson, with my absolute favorite dog in the entire golf turf industry. Will is the superintendent at Laurelwood Golf Club, little 9-hole muni in Eugene, Oregon, and that is Sandy the Chihuahua. And to watch Sandy cruise the golf course is something that is worthwhile. Anyway, to the weather. It was cooler last week, and now we're starting to see the switch change, right? We're about normal, between 3 to 7 days of normal. You got to go into the highest elevations up in the Adirondacks and up in the Green Mountains and into Maine, where you're more than a week behind. Certainly those areas are a little bit behind normal. Almost everybody else, especially with the heat. When we have this conversation next week, you're probably going to see most people going to be normal. Bjarni Harnson tweeted a great picture of early spring grass growth in Iceland, in case anybody thinks their spring is slow to emerge. There's always Iceland. Now, I don't know if we propose to buy this place yet. I know we're planning on buying the other joint, but for now, looking at the grass types here, obviously Bjarni is saying those first 2 rows there of creeping bentgrass, completely straw brown. The next plot, fescue and creeping colonial bentgrass, fescue and colonial bentgrass, then the row of straight fescue, then the row of straight colonial bent. So you can see in this thing, you know, we talk about bent being slow in the Northeast, and Doug, you probably talk about it with Chris Zugel along the lake, right? Where it's really cool, man. You've got to do a lot of things to get the bent grass growing, and probably not the best grass for Iceland golf. Have you been to Iceland, Doug?
Never.
Never.
Mm-mm.
Okay. Bjarni's got to get you there. Okay. you can see we're progressing slowly in the sort of touch points of spring. Like, when is a good time to get a broadleaf herbicide out in the spring? It's never ideal to do it at this time, but this is a good benchmark of when you might get an amine or an ester formulation of a broadleaf weed control product to provide some measure of control. It is not ideal for sure, fall being a much better time, but you can also pick up some winter annuals, as Randy Prostak tells us, a twofer, where you might get some winter annuals before they flower and get some of the perennial broadleaf weeds. And this is from old work at Purdue from many, many years ago, back in the Throssell-Riker days, the ancient days. Okay, what this means is if we're getting ready to spray weeds, it means some of the weeds are beginning to flower. And we've got our pollinator risk assessment, which you can see with this map, is really sort of tracking when you shouldn't be spraying. As it becomes ideal, if you look here, as it's becoming ideal for these herbicide applications, it's also becoming risky for the pollinators. So if you're going to use these products, mow the flowers off as best as you can. If the flowers aren't there, the bees aren't going to be around. And we get a lot of visitors to lawns in the spring, especially with the winter annuals and the spring ephemerals like lesser celandine that might be flowering. Soils are still cool in some places. Again, in those high elevations, you're in the 40s. And then you go down to the Philly area and you're in the mid 60s. And Long Island in the upper 50s, 60s. And these are trigger points now for where many of your root pathogen fungicide applications will go down. So we'd encourage you to keep monitoring your soil temperature and determine. We're going to have Ming Yi on the show at some point this spring to discuss some of the new root pathogens that he is actively finding with his new molecular techniques, which is obviously going to shape the way we do control in the future. All right, pretty dry last week, right? Most areas got very little rainfall. You had to go up along the Great Lakes and northern areas to get the rainfall, but the rainfall's coming. You look at the forecast with precip minus evapotranspiration, and you can see we're going to have an excess of water in some of these areas, and we have another risk model on the forecast website that indicates when that rain comes, there are parts of the region that are at risk for runoff. Listen, we put our pre's down now. We put our broadleafs down now. We put our root pathogen materials down. You know, maybe you're putting a broadleaf down. Maybe you're putting a fertilizer down. We tend to put a lot of things on the land in the spring. Monitoring the runoff at this time of year is really critical just to get a sense of days you should avoid. And you can find all this at the forecast website. All right, we're getting to it now, Doug. Got a couple of guys posting about rolling fairways. Let me tell you how much this warms my heart to see people rolling more. And we're going to take up this topic of traffic and rolling and organic matter because I know Carl's got a few things we're going to chat with you about. But the sort of theme for today is traffic. And it's something that I know you did some work on. We're going to want you to speculate and extrapolate from where you did those rounds of golf in those plots, right, with those fertilizer rates. Remember that from years ago when you did that?
Yeah.
Okay, so here's rolling Jim Pavinetti style at Fairview. And here's rolling Meadowbrook, John Carlone style on Long Island. You know what I mean? Big, wide units, rolling. Everybody's starting to see the benefits of this. The obstacle has been it takes too long. I don't want to use a tractor, blah, blah, blah. But look what's pulling these things, right? These are utility carts now with very wide things. Now, you can get the big Trimax one that Bethpage has got. Then you got to use a tractor. You're getting into the big heavy weights, and very few people, to my knowledge, have sort of studied different rollers on fairways. I'm not sure Nikolai's even studied fairway rolling. But Doug, here's something interesting. Paul Giordano did this work back in 2013, right? Where he had a native soil and he had a USGA root zone, right? And, what came out of this is rolling reduces infiltration. Right? So here's my first question to you. You're looking at a graph here where I've drawn a line at 20 centimeters per hour, right? So that's what, an inch? No,
Yep.
centimeter,
No,
10 inches an hour.
10 inches. Yeah.
10 inches an hour. Okay. Many people will hear people say, oh, rolling reduces infiltration, I shouldn't do it. The 8 times a week rolling a root zone still keeps it at 10 inches an hour. My question to you is, do you care that it reduces it if it's still 10 inches an hour?
Yeah, it just means you can't play during Hurricane Katrina. You're gonna have to take a day off.
One day.
One day. Yeah.
One day. So in your mind, as long, 8 times a week on a proper root zone still provides enough infiltration. How about a different question? What about the native soils that even at 8 times a week are at 10 centimeters, which is 5 inches an hour? Do you get worried there?
No, I mean, and that's native, but it's got to be a
Sandy native.
sand cap, right? So
yeah,
that's why we build sand greens, is because we don't care about compaction. And you're going to have to manage organic matter. That's going to be the thing that you're going to want to manage. But these reductions, even though they're statistically significant, or you see the differences, they don't matter in terms of real life.
Right. So we're talking root zones, Carl, and I know we're going to talk about measurements, and it comes from the great grassroots Wisconsin golf course superintendents. Doug, I think sometimes this is the only place you put this stuff, isn't it? You squirrel it away. If somebody isn't, honored like I am to receive this monthly for the last 30 friggin' years, and writing for it for many years in my time there, I come across this article. I rip it out. You can see it's on my desk. And I was like, Carl, you got to look at this. He's sitting there taking a picture like it's 1970, right? We got to read this thing like it's 1970. Okay, Carl, fire away.
Yeah, so Doug, maybe you could just set up what this research was. There's different volumes of top dressing over 3 years, right? So different volumes of top dressing, different frequencies at which those volumes were applied, and then different sands. So maybe you could set some of it up before we get into the nitty-gritty here.
Jeez, this is so cool. You guys make my slides for me. Wonderful.
Perfect. All right.
Yeah, that's exactly it. So we did a USGA green. We wanted to know, hey, what data-based management is what we're really interested in. So let's start to use some data to make some top dressing decisions. So how much sand should we put down the year? Does the particle size of the sand matter? Or if we apply it weekly, is it any different than monthly? And then, that we're interested in firmness as being something that we're starting to measure more and more. And we realize there's all kinds of different firmness meters out there. So we wanted to see what we got from that. And surprisingly, first of all, fine sand versus standard sand. A lot of guys are switching to fine sands because they think that it's going to give them a firmer surface. But if you look across the sand size category in the middle there, you don't see any differences at all, really. So that surprised us. I guess you do see the GS3 ball picked up on the fine sand actually being softer, but the other 4 devices didn't pick up any difference at all. So one of the things was like, well, these devices are doing different things, they're showing us different things. So which one should we do? And I don't have a great answer for that. But basically what we're finding is a lot of these decisions didn't matter. You see tiny differences here, but the amount of sand you put down, some devices you saw small differences. Other devices, you saw nothing at all. The frequency, very, very few of these decisions influenced firmness, which was surprising to us.
And so the other surprising thing, Doug, and I don't have the organic matter, or maybe I do in the next slide. I'm not sure if I do, Frank, but you definitely saw the organic matter. I don't have the
100%. Yeah.
In the top one, yeah, talk about that, Doug.
Yeah, basically the only thing that mattered. So quality didn't matter. These things didn't affect quality, didn't affect growth, it didn't affect ball roll speed, tiny differences in firmness. So the only thing that really showed up was these decisions do affect the amount of organic matter in your top inch. And when we put down the least amount of sand, we had the most amount of organic matter. So you would have thought, hey, that's going to be a softer green. Not really. When we put down the most sand, we got the least amount of organic matter. That's going to be Firmness. No, not really. And that the USGA is the most amount of sand, and the paste turf is the least amount of sand. So you can kind of scan across there and see and look for those differences.
And Doug, the relative amounts of sand were pretty different. So that USGA was something like, I don't know, 20
Double.
cubic feet per thousand. And the Micah Woods method was like a third of that, right?
Yeah, the USGA method, which is was about like 20, 25, 26 cubic feet per thousand, and the paste turf was 14.
14.
And the woods was in between. So basically twice as much sand from USGA to pace, and then the woods was kind of in the middle. And that's a clipping volume way. So we thought, hey, people are collecting clipping volumes. Why don't we match up sand with clipping volume production? Makes a lot of sense, and it's cool that it fell right in the middle there. But in terms of the biggest differences between the amount of sand, it would be USGA versus PACE, which is a climate-based method. And USGA is just kind of, hey, every month, every 3 weeks, go out and put this amount of sand on regardless.
So let's review the evidence here, Carl. I just want to make sure we're not missing the lead. And I want to take apart two things, three things. One is, when you say fine sand, you mean it meets USGA specifications. It does not meet USGA.
No, it's kind of like the sand they're using at Rutgers, where it's got more fine sand than allowed, but it's not like grossly out of spec.
Okay.
So it's the stuff Jim Murphy's been saying, yeah, this stuff is fine. It doesn't have a negative impact on turf. And it's the higher fines helps the sand get into the canopy of these more dense, newer cultivars.
Okay, deal. But the theory was that's also potentially going to make it firmer.
Yeah.
And I think did not.
Well, I mean, it did, I guess, with no, it didn't at all, actually. And you thought, well, what does a fine sand do? It holds more water. But the difference wasn't related to water content either. So we're just in the coefficient of uniformity, which is the higher the CU, the firmer it is. That fine sand had a higher CU. I can't remember the exact number. I think it was like 2.5 versus the standard sand, which was a 2. Everything was pointing to this fine sand should make it more firm, but it didn't happen. And what my theory on this is, like, it's more about the plant growth characteristics. The sand matters if there's not a lot of roots or turf on top, but once that stuff gets involved, I think the root zone makes less of a difference. But I don't know. We got more to. This is just one situation.
So, and the other thing before we leave this slide is, Doug, could you take a minute, because you did a separate study where you looked at how these different devices correlate to either surface organic matter or soil moisture, as I recall. Could you review for the folks watching and listening, roughly, you've got a Clegg, you've got a True Firm, you've got the PGA method where you drop a ball bearing and measure the dimple depth, and then you got GS3.
Oh yeah. So it was all the data from this study, and we just looked at the correlation between the other measurements we had. And so we saw, and I don't have the slide in front of me, and I'm not gonna, I'm just gonna talk in general. So the heavier devices, so that'd be like the big Clegg and the ball drop, the ones that put more force tended to be better related to the soil moisture. And then the lighter drops, which would be the True Firm, the little Clegg, the GS3 ball, tended to be more correlated with surface organic matter and turf grass quality and things like that, which kind of makes sense to me. Those heavy drops are getting down into deeper in the root zone. The lighter drops are measuring more the grass surface.
Okay, so thinking about what they measure and thinking about what you found here, your theory is that the plant, the soil moisture, which also includes the plant, is not as I'm trying to figure out how, once the plant gets involved, it's absorbing most of what we're measuring.
Yeah, well, I mean, think about as you're putting force down on the surface, the first thing the ball hits is the grass and the thatch, right? And then if it gets through that, it starts to be absorbed by the soil, and the soil strength is influenced by the moisture of it.
That's right.
So if you do a real light drop, it really doesn't have a chance. The grass and the thatch absorb it all. You do a real heavy drop, you still get the grass thatch interacting, but then it pushes down and maybe you get a signal into the soil moisture.
Okay. All right,
Um,
Carl, what you going to ask him about
I,
traction?
yeah. Well, no, now I want to ask you about the organic matter model. So the funniest part about this research is you would have predicted firmness goes up with more sand. Wrong. But what you were able to predict like very accurately was how organic matter changed over 3 years with just this model that has been sort of sitting around. Can you talk about like this Ohio State organic matter model and how is it so good? What do you even put into it to get it so good?
Yeah, well, I didn't do any. Ed McCoy at Ohio State built this with Jeff Broadbelt of DryJect, and so I give those guys 100% of the credit. And I think they made me aware of it. This is probably 6, 7 years ago.
Yeah.
We built it into Greenkeeper, and it's an Excel spreadsheet, and that's how when I go around and talk about this to people, I just show the Excel spreadsheet. And can I do that now? Can I show my screen?
Yeah,
Is that
100%.
okay?
Yeah.
100%.
And basically what you see with it is, and it's kind of complicated, so I'll walk you through it, but it's based on temperature. Organic matter builds up and in cold environments because it doesn't break down as fast. So it's a story about accumulation and decay. So the blue line here, this is Madison, Wisconsin. I just put in the weather data, or the climate data for Madison. So here's how average high is 26 degrees in January, average low is 11. You just go down the line, you enter your average high and your average low in Fahrenheit. And then it shows you, here's how your organic matter accumulates. That's the grass roots growing. And here's how it breaks down by the soil microbes. And that's all a temperature thing, okay? So now, and then, if we grew a warm season grass in Madison, I wouldn't have to worry about managing organic matter because my decay is higher than my accumulation. I also wouldn't have to worry about having a job at a golf course because warm season grasses don't grow, right? So you have to tell what time of grass you're growing. So of course we're all cool season people here. And now let's go to, that's Madison. Let's go to Lake Placid. You just grab the average highs and lows in Lake Placid. And so you just look at the factors here. For accumulation, we're about 1. And for decay, we peak around 0.6. So what's Lake Placid going to look like? Very different. So peaks around 1, you get a little less accumulation because it's cooler there in June and September than Madison, and you get way less decay. So this is your accumulation of organic matter. You got problems up in Lake Placid everybody knows that. I've been up there to Lake Placid and seen the thatch on the fairways. It's not because the managers are unskilled or they're doing something wrong. It's because they just have a massive amount of accumulation. Now let's go to Bethpage down on Long Island. Obviously, very different climate. But again, when people talk about growing grass, New York, it's all the same, right? Look how different that is.
Wow.
You're accumulating and you're accumulating different patterns. Your decay is, you're matching your decay with your accumulation in July and August. So nothing's happening there. And you get the spring and fall accumulation patterns. So do you think that we should be just top dressing everything and aerifying everything the same in New York because it's New York, cool season grass? No, absolutely not. So that's the value of this model. Now you can go, you enter your organic matter contents here, maybe 5% at the surface, 2.5, 1.5. You have to send these into a lab. And this follows the USGA's kind of, organic matter 246 Michael Woods has been promoting. I won't spend too much time on that. But once you enter your organic matter, you have your climate, then it predicts what your organic matter is going to look like for the next 5 years based on your top dressing. So here at soil organic matter in the top inch here at Bethpage, you can see it's slowly increasing. And that's based on these top dressing aeration events that we have. So if you look over here, it says top dressings. So right now I put everything to 0. So no top dressing, no dry ejecting, no hollow tine, no solid tine, no deep verticutting. Now we're going to go back down and see what happens. So if you stop doing everything down at Bethpage, you're going to start at 5%. That's where we are today. And then 5 years later, 60 months, you're going to be at 10%. Not good, right? So we can use this model to say, how much stuff do we need to do to keep our grass around 5%? Now, one of the questions we don't know is 5% good? What about 6? What about 4? I'm just saying, hey, 5 is kind of normal. So we're going to start there, and then we can add these top dressings. So maybe you top dress once a month. Oops, used the wrong one. We top dress once a month, starting in May, June, July, August, September, and maybe we do a holotine event. Do a holotine event in October, and that includes a surface top dressing. That's in the fine print of this model. Let's go back and see how that did. Oh, we're still going up. Now, I don't know. Maybe, again, like, I'm not saying 6.5% is bad, but we might have to be more aggressive than that. And maybe we put in 2 top dressings a month early in the season. Do something like that. And we go down and, oh, wait, that's too aggressive.
Yeah.
Now we can back off on this, right? Let's just let's get rid of that one. Let's get rid of that one. It's a planning tool.
Yeah.
Still going down, right?
And for all the guys who have to schedule out, like, member guests and men's leagues and women, like, by month, this is like a really effective tool to communicate either, hey, if we don't do this, it's going to go up, or hey, maybe we can get rid of some of these, 3 of these holotine events a year and can still maintain. It's and because it's so accurate in your data, like, we're talking less than 0.05%, 0.1.
Yeah, well, right. So the thing I'll say about that is, when I show this off, like, great, it's a model. It could be completely wrong, right? You're just showing me dots. So when we tested it, we did this study for 3 or 4 years, and we started at the start and we entered our top dressing. It was like exactly on, like dead on. And we're like, even I didn't expect that. I'm like, oh, it's going to be close or something. But I mean, if you go, I'll stop sharing here. Well, let me do one more thing before I do that. Let's go. So now look at these operations. This is Bethpage, right? So we got 1 top dressing in May, 2 in June. We'll put this back on down to 1. And, it's going down. So we start at 5, and by the end of 5 years, if we're that aggressive, we're just above 4. Now we're going to go back and we're going to change that to Lake Placid.
Ooh, yeah.
And so same operations, different climate. And we're going to go back here, and it goes down even harder. Now we're down at 3.5. So even though those accumulation patterns were, those graphs were different, you can see you're probably not top dressing in May in Lake Placid, and maybe do 1 here. And maybe you get rid of the September one, and we go down, and now we're at 4.5. So totally different stuff, and it's pretty accurate. I love it as a planning tool and an educational tool. The other thing I learned about it is nothing happens below 1 inch.
Yeah.
Why are we airifying down 3 inches?
Oh my goodness. Oh my goodness. It's 10:30. And if you start that now, we're going to be here for another hour. And I didn't even get to growth and traffic as a growth regulator, and then looking at fertility. But we are at it. And if you wanted to know about top dressing and measuring firmness, I guess I'll ask this one question, Doug, and then we'll let you go. If you use that tool and you're looking at organic matter, you just told me it sort of doesn't even matter how I supply this sand. If I supply enough, right? Enough, it's like the MLS said, it's enough. More isn't better. There seems to be a sweet spot. This is something that's going to take us years to figure out. But you're really saying you can, as Carl said, you can design your top dressing program around your events and not inconvenience people if you just have to get a certain amount out based on your planning. It gives you more flexibility.
Yeah, and the big picture takeaway was the USGA method brought our organic matter to 4%. Cut that in half, we were at 6%. Couldn't tell a difference. If you're a superintendent, you're gonna pick one, you're gonna put half the sand down.
100%.
So what we need to find is what's too much. 6% was great. How about 7? How about 8? You know, that's what we really need to figure out, is where those thresholds lie.
So great. All right, Doug, thanks very much. Carl, glad you could join us, Carl.
I just made it in time to get the modeling stuff that I love.
Thanks, everybody. We'll talk to you next week.
Yeah, see you, everybody. Thanks, Doug.
Take care.
This has been a production of Cornell University. On the web at cornell.edu.